Good afternoon. My name is John Fardoulis from an Australian company called Mobility Robotics. This afternoon, my presentation has two parts. The first part is looking at examples of technology and processes used in humanitarian mine action, followed by the second section covering drones in humanitarian mine action, a relatively new technology. The problem is landmines are not removed after conflicts cease, creating immense problems for local communities, particularly the most vulnerable people. The challenge is not knowing where landmines are actually buried. It's very difficult to pinpoint where to work on removal of such deadly hazards. Two of the processes in the field in mine action that I'm going to highlight today are non-technical or baseline survey, where assumptions are made in the field about where suspected hazardous areas may be located. Typical technology used are GPSs, laser rangefinders, compasses, digital cameras, and other electronic recording equipment to help document where suspected hazardous areas exist. The second process that I'm going to cover is technical survey and clearance, where personnel work inside the hazardous area to locate individual landmines and explosive remnants of war to remove them and render the area safe. A metal detector is a standard piece of technology used in technical survey and clearance, but there is also a range of different forms of technology ranging from advanced sensors through to high precision GPS, even remote controlled machinery. Information from field operations is stored in a number of different ways, ranging from paper-based forms and maps through to entries into tablet PCs and mobile phones, ideally then updated and synchronized with a centralized information management system. The quasi-standard for IM software in mine action is called IMSMA, with the latest version being called IMSMA Core. There are three main categories of assets used in technical survey and clearance. They are people, human assets using metal detectors to find buried landmines, also animal assets who sense where the buried objects exist, and mechanical assets that range from flail machines that disturb the surface to dig up the landmines and destroy them, through to excavators and even remote controlled machinery. Due to the need for safety, demining is a meticulous process, which makes it quite slow and expensive. So one of the goals is always to try and find technology that helps gain better productivity from current assets and other ways to help speed up the process. Here's an example of how the processes take place. In NTS or baseline survey, a geospatial polygon is created to highlight the location of the suspected hazardous area. Then technical survey or clearance takes place, deploying humans with metal detectors or machines or animal assets deployed across the polygon length and breadth in a systematic way. The location of buried landmines is then found using the systematic approach, and they are removed and destroyed. However, a challenge in mine action is that the proportion of such polygons actually contaminated is often quite low. Sometimes even only 10% is actually contaminated, but assets need to be deployed across the whole area for safety. If ways of better pinpointing can be found, significant savings in resources and speeding up the process would be possible. And now for the second part of my presentation, an area that I specialize in, small drones in mine action. Highlights will be shown from the Odyssey 2025 project, which took place in Chad together with Humanity and Inclusion, the High Commission for Demining in Chad, the HCND, and funded by the Belgian Department of Foreign Affairs. Here are some examples to show how low-cost consumer camera drones can be used in a frugal way to capture geotagged evidence of where landmines and other explosive devices may be located, based on accidents primarily. Low-cost consumer camera drones can produce high-resolution maps. Here's an example from the field in northern Chad, where camels were being killed from crossing minefields. The tragedies occurring, providing evidence points of where buried landmines exist. You can see from the map created that there is a pattern where accidents are taking place. We can draw a line along where the accidents have been occurring to give us a good idea of where the mine rows exist. In locations where accidental detonations take place, the drone data can give us a starting point to deploy our ground assets to work from the inside and work outward. In this example, a much more targeted approach is possible, opening lanes from the safe area to where the accidents existed and working from the inside outward. In locations where such a targeted approach is possible, similar levels of safety could be maintained to the systematic approach, but saving significant amounts of time and significant amounts of money by not having to deploy ground assets where landmines do not exist. And now, moving on from small consumer camera drones to small industrial drones with advanced sensors. In 2019, we achieved a world first from drones, being able to capture temperature anomalies from legacy 30-year-old landmines buried in northern Chad. On the screen are two examples. On the left, examples of anti-tank mines that have been buried for 30 years and show a temperature difference on the surface above them to indicate their location. On the right are two rows of anti-personnel mines, also emitting anomalies that show us the location of each landmine. Being able to directly identify the location of buried landmines without accidents or other secondary indicators is a major breakthrough. The example on the screen is a GPS trail of 650 meters over where mines actually exist. So this is an even better use of the inside outward methodology, because we can send our ground assets directly over the top of the mines and they can work from there outward. Small drones provide a great deal of utility. Examples we just reviewed were in a desert environment, but there are also use cases and indicators in many other different environments, ranging from rural and vegetated through to urban and even IED contamination. To innovate in mine action, it takes a combination of better processes, applied use of technology, and people-centric approaches to piece all the parts of the jigsaw puzzle together for improved methods. Looking forward, the importance of GIS, geographic information systems, geotagging, maps, data capture with location embedded, information management systems, including mapping, is only going to become more important over time, and small drones are going to be a growth engine for the capture of such location-specific evidence and data in future. There's sometimes hype about big data, deep learning, machine vision, AI. In reality, in mine action, we're at a small data stage. We don't have teams out in the field capturing enough data to justify infrastructure required for automated processing. Perhaps if more drone teams start operating in the field, that will pave the way for the need for more automated computer systems. That concludes my presentation for today. Thank you for your attention. If you'd like to do some further reading, head to my website where there are links to open access peer-reviewed journal articles, videos, and other sample data. Thank you.